Alright, welcome back. Today we are doing section 1.4, scientific research. Every day in the media, whether it's TV, newspaper, magazines, or the internet, you are bombarded with the results of scientific investigations. Many deal with the environment, medicines, or health. As a consumer, you are asked to evaluate the results of scientific research and development. How do scientists use qualitative and quantitative data to solve different types of science problems? All right, today we are going to compare and contrast pure research, applied research, and technology. We're going to apply knowledge of laboratory safety. Here's our vocabulary words for today. When you get to these, you might want to pause and write down the definitions. What is pure research, applied research, and technology? So our first vocab word is right here, pure research. So the types of scientific investigations. Pure research seeks to gain knowledge for the sake of knowledge itself. Malina and Rolland conducted research on CFCs and their interaction with the ozone as pure research, motivated by curiosity. No environmental evidence at the time indicated that there was a correlation to their model in the stratosphere. Their research only showed the CFCs could speed the breakdown of ozone in a laboratory setting. When the ozone hole was reported in 1985, scientists had made measurements of CFC levels in the stratosphere that supported by hypothesis that CFCs could be responsible for the depletion of ozone. The pure research done only for the sake of knowledge became applied research. Here's another definition that you might want to stop and record. Applied research is research undertaken to solve a specific problem. Scientists continue to monitor the amount of CFCs in the atmosphere and the annual change in the amount of ozone in the stratosphere. Applied research also is being done to find replacement chemicals for the CFCs that are now banned. Read the Chemistry and Society feature at the end of this chapter to learn about how research into the human genome. What type of research does it describe? All right, so chance discoveries. Sometimes when a scientist plans research with a specific goal in mind, he or she will conduct experiments and research a conclusion that is expected. Sometimes, however, the conclusion reached is far different from what was expected. Some truly wonderful discoveries in science have been made unexpectedly. The discovery of a nylon was one example. In 1928, E.I. DuPont de Nemours and Company appointed a young 32-year-old chemist from Harvard, Wallace Carothers, as the director of the new research center. The goal was to create artificial fibers similar to cellulose and silk. In 1930, Julian Hill, a member of Carothers' team, dipped a hot glass rod into a mixture of solution and unexpectedly pulled out long fibers such as the one shown in figure 1-4. So here's 1-4. This is nylon. These two chemicals together form a layer, and you pull that out, and that becomes a long polymer, and you can make clothes out of it. Okay. Carothers pursued the development of these fibers as a synthetic silk that could withstand high temperatures and eventually developed nylon in 1934. Nylon's first use was in a toothbrush with nylon bristles. During World War II, nylon was used as a replacement for silk and parachutes. Nylon is used extensively today in textiles and some kinds of plastics. Students in the laboratory. In your study of chemistry, you will learn many facts about matter. You will also do experiments in which you will be able to form and test hypotheses, gather and analyze data, and draw conclusions. When you work in the chemistry laboratory, you are responsible for safety and the safety of the people working nearby. Table 1-2 on page 16 lists some safety rules that you must use as a guideline each time you enter the lab. Chemists and all scientists use these safety rules. Before you do the mini lab at the bottom of this page, which we'll not be doing, we need to read the procedures and we need to understand the safety rules. So when we do labs, we are being safe at school. Okay? You can do this observation at home. The things you need a petri dish, but you can use any kind of small like cup or whatever. Graduated cylinder. You can probably use some kind of measuring thing at home. You need whole milk, water, vegetable oil, 4 different food colorings, toothpick, and dishwashing detergent. So all of these things you'll be able to find at home, and you can read through the steps and do it at home if you would like to. Okay. Here are the safety in the laboratory. I am not going to read these through for you. You should be able to read these on your own, and I will also post a short video that you can watch about safety in the lab. Okay? Benefits of chemistry. It is easy to understand the purpose of applied research because it addresses a specific problem. It is also easier to see its immediate benefits. Yet when a sudden unexpected event occurs in the world, whether it's the ozone hole or the AIDS epidemic, the first line of defense is to look at the pure research that has already been conducted. The products that we use to make our lives easier and more comfortable, and the results of technology applications of pure and applied research. Technology, which is also another vocab word, is the practical use of scientific information. It is concerned with making improvements in human life and the world around us. And Figure 1-15 shows advances in technology that can benefit us in many ways. So Figure 1-15, nuclear power and artificial limbs and joints are just a few of the technology advances that have improved human life. All right, today I need you to go on to Infinite Campus, fill out the form for Section 1.4 assessment. Please also make sure to watch the safety video that's associated with this, and I will see you all tomorrow. Have a great evening. Bye.